Okay, so I talk about gravity-fed water. It's a pretty advanced science. But anyways, I'm not going to explain any of it. I'm just going to go ahead and turn the camera around, and I'm going to show you what you see. So let's go ahead and turn the camera around if I can. And so here we go. This is a water pump. Look how this is the switch. It is in the off position. I'm not going to turn it on because then that would totally fool the experiment. And I haven't turned it on. I haven't turned that pump on since about 12 o'clock this afternoon. We've washed dishes, flushed toilets. I think Drew took a shower, maybe. I'm not sure. Anyways, so I think we might have got one shower in there, but regardless, we've washed dishes and really left the water pump on almost all day. So to continue, here we go. Going upstairs, just documenting this experience and just going ahead and showing you that this is actually very much real. There is going to be no breaks in this video, and I could explain how to do it, but even if I did, you would know what I was saying. And so anyways, it's really advanced science. So we have the sink. Yeah, the pump wasn't on. Here we go. So there we go. Oh wait, that's me. Yeah, so I turned the water on. Now I'm waiting. And here we go. Is this the last of the pressure? That is the last of the pressure. Last of the pressure. Thought I had it on a gravity-fed system, but I'm pretty sure I have some leaks. Because in all reality, if I did everything right, in theory, on a gravity-fed system, it should create a vortex, which should allow the water to flow from the lower or lowest point. Actually, no, that is not correct. So this sink actually needs to be lower than the pool. So the pool would actually have to be higher than the sink. So I was thinking this would work, but I think I made some incorrect assumptions. Now the thing is gravity-fed water systems are very real and can go ahead and have a lot of pressure if you can go ahead and create the vortex. So how you create a vortex is to have continuous flow of motion and energy. That flow of motion and energy is fluid. And with that fluid, that continuous flow and energy cannot be stopped. But if you have a leak, you can lose your flow, and it will deflate. And you will no longer have this continuous stream because as everything leaked out the hole. So if you have air leaks, old piping, and there is no way you can ever be able to create a vacuum, a pressure vacuum, that's not gravity fed. So you can actually run a pressure vacuum and not even have to deal with gravity whatsoever. So long as the water stays submerged, you can go ahead and create this pressure system, a high volume, low pressure system. So what I mean by high volume, low pressure is a not that's only part of it. High volume, low pressure. There's two parts of this. As high volume, low pressure, and then low pressure, high volume. So this gets converted from one to the other. And how we do that is actually the size of the flow, is the scientific term, or the pipe per se. So we go from a larger pipe. So we have more volume. So volume, more volume, and less flow. So as we constrict, we are making things tighter. Well, if you constrict water, it moves faster. If you can somehow trick the water to go faster than gravity, then the water will go ahead and create this infinity loop called a vacuum cluster, I think, if I remember correctly. So this vacuum cluster is infinite and continuous. And the moment you put a hole in this vacuum anywhere in the system, all the water ejects and out all the water comes. So you put a hole in it, and now all of the water comes out of that hole. Oh, can you put the water back in the hole? The answer is, well, if you catch it. So it's all on perspective. If you somehow manage to control that explosion and into some kind of environment that catches all the water, then yes, you caught all the water, but more than likely not, it's going to go ahead and fall onto the ground. So all that water goes ahead and touches the ground. Do we lose that water? Well, it leaves the pipes, but that's a different story. But we are actually talking about the plumbing. So it's really easy to get lost in my conversation. So I'm going to go ahead and allow your brain to decompress. Because if you check the video, we were actually talking about plumbing. We're also talking about gravity-fed systems. And coincidentally, there's a lot of things in this world that's unigraphic. And if you find things that may correlate or relate, that's because a lot of things that I say correlate to other things. Now, why is that? Well, there's universal principles that we have in life. So how does this relate to plumbing? You just said we were talking about plumbing. Well, that's just one thing that we can talk about that actually goes ahead and applies to high pressure, low pressure systems. We go ahead and need to be able to create solidity. And what I mean by solidity is something streamlined, something smooth, something whole. No holes whatsoever. Air cannot leak. If air cannot leak, then water cannot leak. It's easy to make things watertight. But to make something airtight, that is how you make a vacuum seal. So to create a vacuum, you need to be able to create a vacuum seal. Now, we're going to go back to this infinity loop that I was talking about. So now that you've created your vacuum seal, you can go ahead and you got to figure out how to get the water to start flowing essentially at the speed of gravity. So that's about as fast as you can ever get water flowing. But that is not as fast as water flows. Look at a river. How come it flows? Well, you have current. How is that current created? We keep talking about vacuums, but how that correlates isn't quite exactly how you think. That's another complicated issue, how current works. Not going to explain it. You can go ahead and research that on your own, because that is not the point of this conversation. Yeah, so I keep going ahead and trying to bring your focus back to that. We are talking about plumbing and how the vortex and the high-low, the high pressure, low volume, and the low pressure, high volume, and all of these things correlate. Because the thing is, I keep trying to explain, is none of this is actually easy to go ahead and create this infinity loop. And the thing is if you turn your water on and the water doesn't stop flowing, you may not have created an infinity loop at all. You get all excited. Oh, we made an infinity loop. We made an infinity loop. I've been running the water all day. I did the dishes. I didn't get to take a shower. So, yeah, we have pressure that builds up in the line. Just because you shut off the pump and the water's still flowing does not necessarily mean that you actually successfully created an infinity loop. You created a false sense of hope, is what you created. Because really, you're draining all of the water out of that line because there's an air leak. And what happens in NASA if you have an air leak? But this isn't NASA, this is plumbing. And so, not having any air leaks isn't easy. I keep going ahead and saying none of this is actually easy, but it is very much attainable. I went ahead and I have a very large plumbing system, 6 bathrooms and 6 toilets, and I will go ahead and I will successfully show you that I'm taking a shower, because the thing is about most pressure systems is, well, at least ours, we have a 20-gallon pump and maybe 20 gallons in line. That's about normal for your average house. Now, it doesn't really matter how many toilets, bathrooms, whatever. Our typical pressure tanks are 20 gallons. Some very large houses have up to 120 gallons and even larger pressure tanks. What the pressure tanks do is they retain the pressure. So the pump doesn't have to turn on every time you turn on the water. Because if there's no pressure tank, well, you have to wait for the water to go up and back down the pipe. Oh yeah, and you need check valves too, because if you don't have check valves, Well, the water flows backwards, and then you lose all your pressure, even if you have a pressure or a tank. But if you don't have a check valve, you can't even build up pressure. So, what is a check valve? A check valve restricts motion or energy or anything going backwards, retaliating backwards. It stops the motion or the flow from going the wrong direction that you want it intended to go. So it has one simultaneous and only one direction of flow. If you have too many directions of flow, you can go ahead and confuse the vortex and lose it. It'll create pukas in your matrix. And I go ahead and I keep talking about how does this relate to plumbing? How does this relate to plumbing? It sounds more like time travel. Well, you know what? The flow of water and time travel is very much the same. The flow of water is energy. It's living energy. Time and water. Time, water. Time in water. Time is of water. Is time water? Or really it don't matter. But time and water, how they correlate, is very unique compared to any other element. I can say that about any element, really. But it is definitely interesting how these two specifically correlate. Time and water, they both flow in one direction. Water does not flow backwards, and it does not, surprisingly, it doesn't flow forward either. It flows in one direction, simultaneously interweaved and connected to create a flow. So it's not one simultaneous flow, it's multiple streams that creates a current. And these words, stream, current, and river, or water, these are all of the earth and the old ways of thinking, the hermetic ways of thinking that no longer is taught because it is handed down to very few. So those that are taught can teach. And very few words were ever given because what was taught was meant for very few. But these are stories they told me, all to tell to you. Riddles and rhymes and trickles of time. How does these riddles ever relate to water or time? I don't know. Does it matter? Because there's current and flow. There's vortex. And I say it with a rhythm because it flows. How does rhythm and water and all of these things correlate? The thing is, they very much all correlate. There are many things that correlate. So to go ahead and say one thing is true. But many things are true and many things correlate. So if I give you an apple and an orange, does that correlate? Well, I can make a smoothie, make some yogurt, or I can say that they're moldy until you know. Then again, it's all in perspective. One apple's moldy, but the orange is green. Well, I cut off the mold, and I know that that little bit of green is going to actually give me like this nice sour taste. And I could have picked a ripe orange, and I could have picked a ripe apple, but that little extra age and that little extra green, unripe, that combination, and the citrus super sour, and the overripened apples, a lot of sugar in the overripe apple, and a lot of sour in the unripened orange. And so now, instead of that was actually intentional. It wasn't any kind of punishment, and I wasn't given a moldy apple and a freaking nasty and a sour orange. No, that's your perspective on what I said, because I said nothing of the sort. I grabbed the moldy apple because I know it makes extra sugar, because I'm trying to make a very sweet and sour pie. And that's why I grabbed the green orange, not the right one, because I know what I'm looking for and I know the flavor. I didn't grab anything too early, and I didn't grab anything too late. I grabbed it all just in the right time. And that is the thing about time. It's all about timing. And time is linear. And everything is in the right timing and the right flow. If you don't have the right timing, then you don't have the right flow, and then you'll never create the vortex. And like, if I said it was that simple, I'd be lying and telling the truth. And that's duality, because it is a duality. It's paradoxical and infinite. It's easy, but that's only because you figured it out. You haven't figured it out. Because I haven't figured it out. The fact that if I say that I figured it out, then how would I ever open up the portal? Because I never have. Or how could I ever find it? And the thing is there's this idea that you know everything. And that is a fundamentally flawed part of reality, because as a scientist, we have to accept that everything we know may not be, but it definitely could be, inherently flawed. I didn't say wrong. Flawed. Kind of right. Half-assed. And that's not quite what is going to get you anywhere in life. Half-assed truth. Well, that half-assed truth got you that half-assed job and got it halfway. Only halfway. But not to be inappropriate. Thing is your glass half empty? Oh yeah, half empty. Oh yeah, no, shut up, listen. Is your glass half empty or half full? Now you think you know what I'm going to say. It doesn't matter what you think I'm going to say about this, because, well, if you think you're right, you're wrong, and if you think you're wrong, you're right, and if you're wrong, it really doesn't matter if you're wrong or right, because it's not about being wrong or right. It's about the glass, but you think it's about being wrong. I'm wrong. I'm talking about the glass. I'm right. I'm talking about the glass. Thing is, that is actually what we're talking about. We're talking about right and wrong and the class. But you're still talking about what's right and what's wrong. And I'm trying to just talk about the damn glass. And I'm just saying it's half empty. You want me to top it off? I haven't even finished it. Why? Wait. You want me to top it off? Now, well, that's all in perspective, really. Because you think, you didn't listen, you didn't pay attention, and you didn't change it either. You let it happen. And you anticipated before it ever happened. And you're right. You anticipated that they were not going to top you off. They were going to. That's actually what they're paid to do. But because you thought that whatever, because they're coming up to your drink and you just didn't want to be bothered, and you're talking to your wife and you're like, hey, shoot, get out of here. But really, they just kind of thought you were an asshole because they wanted to give you more coffee. Because that's actually that's what they get paid for. But no, they're just the dumb waitress that has 3 jobs and 6 kids. Well, probably not 6 kids. Who the hell can afford 6 kids these days? Just one that they probably can't afford. An upstairs apartment that's way too small, basement and size about size of a twin bed. Well, that's way too much of an exaggeration. But maybe one day it won't. In China, that's kind of how it already is. You get the size of a freaking twin mattress. A little bigger. Space to live. Appreciation. None. Look what I gave you. What do you think? I'm being rude? Appreciation is the subject. What are we grateful for? How does that, yet again, relate to plumbing? No, seriously. You wipe your ass and don't flush the toilet. How do you think that toilet flushes? Yeah. So, we live in a world where just about every single home, at least in America and most modern countries, have flushing toilets. And this is a luxury. Right? It's a luxury to have a flushing toilet. We used to have to throw our shit out the window and just get diseased and rats, and die. Like, that's what we used to think was okay, and because everybody did it. There's nothing wrong with it. It was your perspective. And everybody did it. And if everybody still did it, well, there probably wouldn't be anybody left. But, poop causes diseases. That's why we flush it down the toilet. So you go ahead and you flush it down the black hole, and it's gone for eternity. Once it goes down the black hole. So there's a lot of theories about black holes, and the thing is who knows what's right and who knows what's wrong. But I have a lot of questions and a lot of ideas about black holes, and I have very interesting perspectives, as you can tell. Moved along, and yes, if you thought so, I was going to say it. Plumbing and vortexes. Oh, no. Hold on, what were we talking